Hi, good day, everyone. I'm Luca, Head of Offensive Security at Bentley Systems by day and Internet of Offensive Things Maker by night. In this talk, I will present USBsamurai, a neat open source hardware implant that can be disguised, among other options, into a USB cable. Despite during the years, we have witnessed many attacks perpetrated with the help of USB flash drives. As you can see here is a little excerpt of incident happened in the ICS world, Industrial Control System world, about related to USB drives, flash drives. Even in the recent times, we have witnessed attacks against cryptocurrencies holders. In this case, a user on Reddit reported receiving a ledger, supposedly original ledger Nano X, which ended up being weaponized with a USB flash drive. As you can see here on the top right image, we can clearly see when it popped open the weaponized Ledger Nano X, that a flash drive was attached to the original PCB of the Ledger Nano X. And on the bottom right, you can see that the original PCB didn't have such kind of implant, such a kind of USB flash drive. Though, as well as this June 2021, Honeywell published a report about USB threats, with a surprisingly increasing usage trend by 30%. And out of these increasing usage of USB flash drives as entry point for attacking industrial control systems, 79% of the malwares contained in those flash drives were perfectly capable of disrupting OT infrastructures. So as we have seen so far, there are plenty of known reported incidents related to flash drives. Though, now let's think about a very common misconception. USB devices are not only flash drives. In the past years, I've presented different kind of hardware implants, like we will see later, related to USB protocol, but they were not USB flash drives. And here you can see a couple of USB devices weaponized with those kind of implants. Here, for example, we can see another trend, as I mentioned, related to USB devices, but not only flash drives. So in this case, for example, some users reporting being targeted by sort of real spear phishing, physical spear phishing attack, where they were receiving like a mail with included USB devices that was acting as a HID device, injecting device, or in the case of a power plant which was hit by a ransomware attack through as well a keystroke injecting device. In the recent years, new attacks were discovered also utilizing more advanced USB-related hardware implants, like in this case, where the malware XFS direct targeting ATMs was deployed by using a POMPI. We'll see later what is just briefly a POMPI, but is a hardware implant, right? And here again, in the darknet forum, there are threat actors selling similar devices, for deploying malwares as well in ATMs as in corporate networks. So it's not just fiction; it is a fact. Beside USB flash drives, there are other type of USB-based devices that can be misused by threat actors to attack corporate networks, industrial networks, or end users. So starting with the very beginning, back a few years ago, me and other researchers started releasing similar open source offensive hardware implants in order to create sort of awareness among security officers. The first generation of remotely controlled devices were with injector and POMPI, approximately released around 2017, both quite cheap to to quite cheap and open source. So anyone could modify their sources. Um, followed by with Elite the year later that had even longer operational range. So if with Injector and Pompeii had Wi-Fi as main remote control, um, with Elite could have been controlled through GSM network, 2G network, which despite being deprecated in some countries is still fairly used in many other continents. Like in Europe is still there and will be there for a while, as well as in India and other countries. So it had very good long range and plenty of capabilities. As soon as these slides will be released, you can see that there are URLs there. So just enjoy those. And here a practical example of what you can do with Elite. You can disguise it in a keyboard, and voila, job is done. So with its LiPo battery, can run for hours and hours, uh, even without any kind of power from the USB port. And of course, once plugged, can remotely inject keystrokes and eventually also bypass air gaps through the 2G network. Afterwards, yet another set of malicious open source devices were released. Joel released in open source in 2019 𝐂𝐄𝐂𝐊𝐄𝐃 cable and 𝐂𝐄𝐃𝐃 keylogger in 2020. Both were malicious hardware implants, one disguised as a USB cable and the other one acting as a keylogger implant to be installed inside a keyboard, let's say. Eventually, in the middle of 2019, one evening, I had the idea to take a vulnerable Logitech unifying dongle, vulnerable to mouse jacking attacks, of course. And if you never heard about mouse jacking, I strongly recommend you to have a look, because mouse jacking attacks still nowadays, despite Logitech and other manufacturer released updates to their devices like mice, keyboards, presentation pointers, there are plenty of those devices vulnerable nowadays in corporate environments like buildings. So if you just go around and do sort of mouse jacking, word driving around the target building, most likely you will find at least one of those vulnerable devices still there connected to a machine. And then will be just matter of a few minutes to inject, well, actually seconds to inject whatever you want, like PowerShell, one-liner, or whatever comes to your mind. In the meantime, Marcus, uh, aka MAME82, started reverse engineering Logitech RF devices just to, well, I guess the main idea at the beginning, the initial idea was to check whether Logitech succeeded or failed on patching those devices from the previous mouse jacking attacks. Eventually, discovered a bunch of vulnerabilities and released in August 2019 two amazing tools, Unifying and Logitecher. So after that, we had some brainstorming and decided to merge the two ideas of vulnerable, of a USB implant, hardware implant, based on this unifying technology, shock burst technology, and is Logitecher framework. So and then you know we the rest is history, as I mentioned in these slides. USBsamurai was born. Um, in short, what do you need to create a USBsamurai? Here there is a QR code that goes to the blog post I wrote about, with instruction how to build it. It's fairly simple. It's just, matter of patience and, steady hands. Anyway, first of all, what do you need for from the attacker side point of view to control remotely your implant, either, as you can see in the image, a weaponized USB device or, USBsamurai cable? Well, you need a NRF52 840 based TRX transceiver. I usually prefer this one that has an external antenna. You will see all the links in that blog post, of course. And this allows, once plugged in into a computer or into your OTG cable and phone, to connect to its serial interface, and then from there you can control the Logitech framework, which will then send issue commands to the USBsamurai implant cable. Then you will need, of course, a Logitech unifying receiver dongle. We'll see in the next slides where to get them. Of course, a USB cable where to hide, sorry, the such unifying dongle, and then the usual do-it-yourself electronics tools like soldering iron, tweezers, magnifiers, etc. The most important, you will need patience and steady hands because it's very critical to have to be very patient while mounting the cable or the unifying dongle in order to not break any of the SMD components on the PCB. So at this point, you have multiple options for the unifying receiver. You can either reuse some of those receivers dongles that you have at home from your Logitech, older Logitech devices, or you can just go on Amazon, for example, and buy those. The most common and quite available on the market are two: the CU0007 here on the right of the image of the slide, and the CU0012 on the left. I personally recommend to use the CU0012 because flashing it with the Lightspeed firmware, which I provided, by the way, in the how-to blog post in the previous slides, in the QR code, you will be able to reach very fast keystrokes injection speed. Example, just to give you an idea, to type the entire client agent, which we will see later in the next slides, for the air gap bypass, it will take only 30 seconds instead of the usual default 2 minutes that you can achieve with a slower unifying dongle firmware. And then the covert channel will be also encrypted by using the CU0012. And of course, this is in general for all these kind of for all the unifying dongles, since it's a proprietary protocol running on 2.4 gigahertz and not the usual Wi-Fi, Bluetooth, low energy protocols. It will be not easy to detect it. So it's perfectly is the perfect weapon for a pen tester or red teamer to have fun against blue team members. Is using an uncommon wireless protocol, can be disguised as a USB cable or a USB mouse or whatever, weaponizing any USB device, and it's that cheap. You can build it out of cheap components out there already mounted pretty much. I mean assembled, except few wires to solder. USBsamurai is quite easy to assemble, though by default it doesn't allow data connection, right? Because between the PC and the charged phone or tablet, because what we are doing, generally speaking, as you will see in the blog post, we are taking just the VCC, so the +5 volts, and the GND, the ground wires from the USB cable and solder to the unifying dongle that was inserted inside the USB cable of the USBsamurai. Though if you need such kind of feature, so you need data exchange between the charge phone tablet and the PC or whatever, you will have to add also a nano USB hub. It's not impossible. It's kind of tricky, so you need to double the patience and the steady hands in this case. But it's definitely doable. As you can see in the images here, there is the unifying dongle, the USB Nano, which is perfectly fitting the a USB male connector, and then mount it all together, and you should be fine, ready to go. Now, once done building the cable or any other weaponized USB device, you will have to pair it with your own NRF 5284 zero dongle. So let's call it the attacker antenna or attacker TRX. This one, just to be clear. Both NRF 52 dongle and unifying receiver, so USBsamurai, for example, has to be attached to your laptop before proceeding. So in this case, in the screenshot, you can see that on the left, I started running unifying pair. Just remember using sudo. And then after starting that, it will stay running and waiting for instructions. On another terminal, you just need to run in the Logitech serial connection interface pair device run. In this case, the two devices, so the antenna, well, the transceiver TRX and the USBsamurai will be paired together. So there will be an exchange of a key, the encryption key, and will be stored in the flash memory of the transceiver. Another important thing is that every time you will turn on your Logitech, what I mean turning on, plugging into your laptop or in your phone, you will have to load from the flash the pairing data. And that can be achieved very easily with storage load and the MAC address, so-called MAC address of the USBsamurai itself. So, of course, you can use multiple USBsamurais at the same time with one transceiver. So as soon as you define the right address for each, you know, of these cables, you are ready to go. So here, a simple example of, you know, how to create a script for injecting, you know, I don't know, some, in this case, a harmless, you know, fake WannaCry infection. So in this case, you plug the antenna here on your PC, on your phone, that supports OTG, of course, connect over its serial connection. So you will see that Logitech, you know, title there, and then type something as follows. So script, and then with the initial command script and the following arguments, you just tell Logitech that you want to create a new script. So script press UI. So you write down your own script. At the end, most important part, you need to store to save it, right? So script store, and then the name of the script. In this case, you know, WannaCry. Once it's done, we can load it back from the memory of the antenna of the transceiver with the command script load, and then the name of the script that, you know, we just created, and then eventually you can even write script show to see what is loaded in memory right now. So for example, you know, the fake WannaCry infection we just, you know, wrote. Eventually you can even set this script as default one. So in this case, you don't need every time every time you plug the Logitech into, well, the TRX Logitech based into your phone or laptop. You just need to go in the options. So option inject default script, and then define write down the name of the script you just created, in our case WannaCry, and then option store to save into the flash memory. And then, of course, if you type options show, you will see that, you know, it got, you know, stored the right option setting. And now demo time. So in this case, in the short demo, you will see the previous simple script in action. This will give you an idea of how simple it is to operate a USBsamurai and how fast is the keystrokes injection. So let's see if it works. So this is a USBsamurai that gets plugged into a machine. In this case, just, you know, a fake, you know, nuclear plant, just, you know, to give you a better idea of, you know, the possible impact. You connect the antenna to your phone, open the serial connection, and then, of course, it was already paired, loaded the MAC address, well, the address of that USBsamurai. Then you define, you know, inject target address of that specific USBsamurai, and then just execute the script that was preloaded at boot, as we seen before. So as soon as I press inject, few seconds, and you're done. If it was a real malware, a real ransomware, the victim would have been infected in a couple of seconds, and that's it. Yeah, pretty cool. Okay, next. So arrived at this point, we will review my favorite feature of USBsamurai, the air gap bypass. So first of all, for the ones of you who never heard about that and never really understood what it is, what is an air gap? It's a machine or a group of machines completely isolated from a corporate LAN or internet. So the air gap practically makes them more difficult to get hacked, and of course you need some sort of direct or indirect physical access to them. And here comes in the weaponized USB device, because sometimes, well, let's take the example of Stuxnet contractors that didn't know what they were bringing in, brought inside the Iranian nuclear plant infected USB flash drives. Now imagine that instead of a flash drive, nowadays are forbidden or strictly analyzed with hardware and software, USB firewalls and intrusion detection system and antiviruses. You bring inside the plant a USB cable. How many engineers wants to charge nowadays are charging their phones with a simple USB cable over their workstation or HMI? Is not a good, is a violation of many policies, but who cares? Plenty of them, they are still doing that, unfortunately. So there are ways to get a USB Samurai plugged in into a plant, for example, in an air gap. Unfortunately for us. So now that we got a generic idea of what challenge we are facing while attacking an air-gapped environment, this is a walkthrough of what happens under the hood once a USB Samurai is in use. So first of all, of course, USB Samurai gets plugged in into the target machine, right? Attacker then remotely connects to it, as we have seen in the previous demo, and then deploys the agent through the keystrokes injection. Agent is a .NET compiled source that you will see in the last slides, the source code, so in case you want to have a look. The agent then starts listening for incoming data over the HID++ interface. We'll talk a bit about that a bit later on, just stay with me. Attacker then gets a live shell and sends commands back and forth between the antenna and well, the TRX, Logitech TRX, and the USB Samurai. So practically is created this agent that is injected into the target machine, creates a sort of raw HID channel, a cover channel over USB between the victim machine, over USB to the USB Samurai, and then USB Samurai sends radio packets undetectable from classic wireless Wi-Fi intrusion detection system to the Logitech. This way we bypass the air gap practically over a radio cover channel. Then what happens? Logitech sends invalid HID++ RF frames with arbitrary data in it, example our commands, and USB Samurai relays them to the USB host. So USB Samurai relays the packets, radio packets, to the target machine. And in case, not always is installed, but in case the victim machine has Logitech software stack installed, it ignores them, so it doesn't care about these, malformed packets, just ignores them. But in the meanwhile, our agent, which is listening on that, raw HID channel, receives them too and takes care of the commands that were issued by the attacker. So what it does is then the agent execute the commands like, I don't know, who am I, or ipconfig, and then takes the std out of those commands and send back over the HID++ tunnel, and the attacker remotely received the std out of the command executed. This is in real time, so I mean, the attacker won't notice all this, all this workflow. It will be pretty, instantaneous, like. So, talking about HID++, Logitech USB dongles use a raw HID channel for the HID++ proprietary protocols. As you can see here, there are some images from the official specifications of this product. It's proprietary, designed by Logitech. Why is it there, such kind of protocol and HID++ interface? Is because some Logitech devices like presenters or smart keyboards, like for example, I have one here that is a sun-powered keyboard which sends back the level of the battery level to the Logitech software stack installed on that's supposed to be installed on the computer. So they created this interface to work as as a side um, protocol to exchange data. So the injected agent acts as a sort of bridge which forwards USB HID reports coming in and out the unifying dongle via radio to STD and STD out of a CMD exe process, and that's how we get the real-time shell. A peculiarity of this protocol is that invalid messages, as I mentioned before, despite being replied with an error, are still transmitted over radio. So therefore, an attacker using a Logitech dongle can send these malformed HID++ packets containing arbitrary data that will be forwarded by USBsamurai, for instance, our Logitech unifying dongle, to the raw HID channel and will be received by our agent listening on them. As I mentioned before, just briefly. So in this case, we can send malformed data, so radio frames, including this kind of HID++ proprietary protocol frames, malformed, that no one will care, will just be blindly forwarded to the next destination, and that's what exactly we want to achieve. In that way, we can get our agent just keep listening to incoming data and forwarding other data through this the entire flow tunnel, and our Logitech TRX will receive them. So there is a completely covered channel, uninterrupted and undisrupted by no one, which is nice. And of course, we don't need root access or admin access to do that. So it is perfectly working with low level access permissions on a Windows machine. Here, another excerpt of the original Logitech specifications about HID definition. So, as I mentioned, is a protocol that has different characteristics, and why is used is because, like for example, here, let's see if he's mentioned something like battery level. Mm, okay, not necessarily in this part. At least I can see now. But yeah, it's definitely used for exchanging such kind of information, and we can misuse it. So yeah. So now that I give you an idea of how it works, the air-gapped bypass feature, let's have a look into a practical example. Attacking an air-gapped PLC Modbus server from the engineering workstation. So before the video, I wanted just to give you a short explanation in a way that you will understand better the entire proof of concept without me discussing too much and distracting you too much while talking. So first thing, for this air-gapped bypass demo, I created a simulation of an air-gapped industrial plant. Which means no connection with corporate network, no connection with internet or other segments of the OT infrastructure. So practically there is just on the left a PLC Modbus server and its virtual representation of the plant. As you can see here, this is a simple virtual representation of the plant itself, just to give you an idea of what is happening. On the right side, we have the HMI or engineering workstation running a usual Windows 10, and here we have just a simple router, just interconnecting the two machines with no internet whatsoever, Wi-Fi or no LAN to any internet connection. So these two machines are connected each other, but air gapped with the rest of the entire the rest of the OT network and internet. Somehow the attacker managed to get its USBsamurai plugged into it. As I mentioned before, in one way or another, that's obvious. It must be plugged in. No magic happens otherwise. The industrial plant simulated is a toxins pre-treatment unit, where a tank is filled with a mixture of toxins, toxin agent, and water, which then are separated by a vessel. And in this simulation, there are different sensors and valves. Here, for example, tank level sensor, vessel valve, water valve. Here there is another valve here for the tank. And here there is the feed pump. So yeah, another sort of valve that keeps filling the storage unit. The attacker goal is to fill the tank until it explodes without alerting the field engineer looking at the HMI. Does recall you something? Yeah. I wanted to create sort of scenario like it happened with the Stuxnet. In that case, the malware was playing with the Siemens PLC in a way that the turbines were misbehaving respect the usual behavior in a way that they were getting um, they were more consumed faster. So their lifespan was reduced dramatically. In the meantime, they were modifying the results that the field engineer were seeing from the HMIs and engineering workstation in a way that they were not getting any kind of alerts. For them, everything was operating normally, so no one was ever, aware of what actually was going on inside the turbines. So in this case, the attacker deploys over the air gap bypass cover channel a payload which will write for 120 seconds, 2 minutes, some Modbus registers on the PLC to achieve three things. First of all, keep filling the tank by enabling the feed pump register on to 1. So in this case here we'll go to 1 and we'll keep filling the tank. Sadly, this is not the only thing that the attacker has to do to let the tank explode. The second thing, he has to keep the tank valve closed here by setting the level sensor register to 0. So here, as soon as these will be kept to 0 in a way that, if there is starting an overflow, normal behavior will trigger an alert, everything will be blocked, this will be left open, and, toxin will not be spilled. But in this number case, the attacker will just keep this to level 0 in a way that everything will look, um, will not be open the valve of the tank, and eventually the tank itself will explode. And then to keep everything under the hood, like stealthy, let's say, we'll disable the spilled alerts on the HMI by tempering the register value to 0. In that way, here you can see that there are this is the HMI. So the field engineer will see this kind of UI on his engineering machine, workstation, HMI, and here we have a threshold. In this case, I set to like few liters. So until there are less than 3 liters of spilled in the spill status, there will not be trigger any alert. But in case there will be more than 3, there will be an alert, and everything will fall in the fail safe. So the tank will be forced to be emptied, the feed pump will be stopped, and so on. So in this case, at the beginning of the simulation here, there was a minor leakage of 1 liter. So for us is not an alert, right? So now that we have seen this, we can start. Right. And once the attack stops, the tank already exploded, of course, because as you can see here, it got spilled, right? We will see the video just in a second. The tank already exploded, and only at that point, when the attack stops, as I mentioned, it was lasting for 2 minutes, enough to explode the tank. When the attack stops, the script I injected will not anymore tamper the register values to 0 of the spilled alerts, right? So in this case, what will happen is that boom, magically from 1 liter spill that is not an alert, not an issue, will magically jump to 199 liter spill, which that's another magnitude of problem. So you will see that it works perfectly fine. So just give me, okay, here. So as I mentioned, here is the USBsamurai that gets plugged in, a simple cable. Actually, the cable itself is from a real iPhone cable, lightning cable. I just modified. It's still packed with the Apple official packaging. And here we have, as you can see here, no connection with the internet whatsoever. And then the attacker, meanwhile, the toxins pre-treatment unit is working as expected. Everything looks fine, but in the meanwhile, the attacker starts, injecting well, first of all, the air gap bypass agent. So now, despite you don't see anything being typed on the screen, the USBsamurai is still injecting the payload. As you can see on the left side of the screen, USBsamurai is keeping injecting, the hex payload, then will be executed. It takes approximately 30 seconds. Once executed, we can eventually connect to that cover channel, eventually issue a who am I, just to be sure that we have a real-time shell working, and then we can use our macro, in this case pawn PLC 120s. It should be 120 seconds, as I mentioned. And here it comes. He's injected this this Python script within that real-time shell session we have within the cover channel. And as we can see now, slowly, so we already have 1 liter spill. So it actually is a bug of this simulation. I started already with 1 liter spill, but that's not a big deal. So it's not an alert. So no one got alerted yet. As you will see now, the tank, instead of getting emptied because it's surpassing the tank level sensor, is still going up. And boom, the tank exploded practically. As you can see, it started to spill lots and lots of toxins outside the tank itself. And in the meanwhile, the toxin spill status on the right side is still set to 1 liter. Nothing changed. And that's the beauty of this kind of attack, right? So the field engineer didn't get alerted. Meanwhile, on the other side of the plant, toxins are getting spilled out of the tank itself. On the other side of the plant, toxins are getting spilled outside the tank. And this for, of course, arbitrary time as 120 seconds, as I set inside I programmed inside the Logitech macro. So now the tank is, the tax is successful. And as soon as we'll end up this 120 seconds execution, we will see that everything will be kind of restored to normality. So when the attack stops, the real value appears. And 3, 2, 1, boom. See? 120 liters spill and increasing. So only now we know, only after the incident happened, the field engineer realized that something bad, was going on. But eventually it's too late. Toxins were released, and eventually we started to have casualties. So now we can start to exfiltrate some credentials as well. We have macros. So in this case, I issued another macro command. I recorded into the Logitech firmware to extract credentials from that working station. Just in case, you never know, we need them to for using on the OT infrastructure, or try to connect over some VPNs or anything. Why not? And of course, another macro I deployed into Logitech here is Wi-Fi creds, bank Wi-Fi creds. So in this case, well, yeah, Wi-Fi thief actually is called. So he's stealing is a simple PowerShell one-liner that steals the Wi-Fi SSIDs and passwords of the target machine. This is just a simple proof of concept to prove you what you can achieve over the cover channel. And of course, in the meantime, the attacker, the victim cannot see anything because as we see, the real-time shell is not shown on the screen of the victim. So the victim is practically unaware of that. So pretty cool attack with the bypass air gap. So just to recap, of course, you can read the same on the either on the Logitech README or on the blog post I mentioned before. But just to recap here are the instruction on how to inject payloads and how to bypass an air gap machine. So just as soon as the slides would be available, you can use them as sort of cheat sheet. Of course, you can mod the sources to add your own scripts and macros to be injected like I did for the PLC hacking or dumping Wi-Fi passwords or other credentials. Here are a couple of resources to the sources in order to get started. So here, for example, Logitech mini sharing, and then the cover channel agent. I wanted to thank personally Rogan to have taken the responsibility of taking care of these repos since Marcus decided to get a pause on maintaining them. So that's well, that the time is over. That's it. I hope you enjoyed my presentation, and I like to thank Marcus and Brogan for the immense contribution to the offensive open source community. And feel free to join the QA session or reach me on Twitter or LinkedIn for follow-up questions. Take care, guys, and stay safe.